Okay, good morning, everyone. So today is Friday, week 4. We're almost halfway done. So we're gonna get started on today's lecture. Today we're gonna learn how to solve systems of linear equations. This is chapter 4 of your book. All right, so I started y'all off with this warm-up. So let's start off with a little bit of math review. So who can tell me what are the unit vectors? IJK, all right. Someone else want to add? So what is the length of a unit vector? 1. Okay. So what is so I hat? Which direction is I hat pointing? X direction, horizontal. J hat is pointing in the Y direction, and then K hat horizontally in the Z direction, right? So the unit vectors are the basis for defining our Cartesian coordinate system. So how do we define them in MATLAB? How do we define let's give it a name, right? I hat. So it's a unit vector. So that tells us that we have brackets. So what would I put for I hat? Good. And then J hat. J hat. Nice. So notice how I have these. Let's put this in a matrix form. So I'm just going to call this a matrix. And then if I have I hat in the first row, J hat in the second row, and K hat in the third row, and then if we run this, notice how we have zeros down here on the bottom and zeros up at the top. And so what do you notice at the diagonal? What's the diagonal of the matrix? Yes, this is in fact an identity matrix. Very nice. So that means that we have ones all along the diagonal. Okay. So keep that in mind as we talk about today. Keep that in mind for the rest of the class because we're going to be dealing with matrices the entire quarter, right? Okay, who can tell me what is a function? You know this. Yes? Lexi? Good. Very nice. Thank you. Anyone else want to add? Takes in an input, produces an output. All right. What about for loops? What is a for loop? Yes, exactly. You're just repeating the commands and many times. And then, so who got started on this system of equations? So did anyone solve this algebraically? Yes? You got three variables? You did it manually, mathematically? Okay. So today we're going to learn how to solve a system like this using numerical methods. So if we have three equations and 3 unknowns, did we learn a method for solving this previously? A couple weeks ago? Remember Cramer's method? Cramer's rule? So what did we need to take in order to solve 3x3 systems? The determinant. I heard it. Very nice. So today we're going to learn how to solve the system of equations. And so I'm going to define this as a matrix in MATLAB. right? And so I'm gonna have the matrix A, and then I'm gonna type in that matrix, right? Hopefully that's right. And then B is a vector. And then, so let's output that. Let's see if this is what we expect. This should be a column vector. All right. There we go. So A is what is the size of A? 3 by 4 or 4 by 3, right? Let's check. We can always use the workspace to check what is the size. It was 4 by 3 because how many rows are there? 4 rows. How many columns? 3 columns. And then B, what is B? It's just a single column vector, right? So what we can do is we can augment these two objects. So augmenting, we're just putting them together. Sometimes we get confused. What is augmenting a matrix? It's nothing. It's just copying and pasting them together. So I'm going to call this augmented matrix A and B. And let's run that. So I took my A, I took my B, and then I just copied and pasted them. So now my augmented, so what is my augmented matrix? What is that size? What's the size of the augmented matrix? Yeah, 4 by 4. Nice. So do we see how we augmented the matrix? This is the first matrix, and then B is the second matrix. And then, so again, I'm gonna try to keep repeating this because sometimes, MATLAB has some nice features. And so if we have the form Ax equals B, we can use MATLAB to calculate this automatically. So is it technically possible to do matrix division? Like, is there a real thing called matrix division? No. But there is matrix inversion, right? So if I multiply both sides by the inverse of A, then I'll cancel out A, right? And then I'll have B times the inverse of A. So pretend that's kind of like your matrix division. So MATLAB has that. I believe it should be X equals B backslash A. And then I believe that will give us the answer, if I'm not mistaken. I believe so. Is that what y'all got for your numbers? No? Something different? Let me just double check real quick, make sure. Yeah, I think that's it. So MATLAB solved these automatically. Today, we're gonna learn how to do that. We're gonna learn how to solve these matrix operations manually. Let me just double check real quick. I think this is correct. Yeah, I have to verify. I'm gonna verify because I messed up in the last class as well. So I'm gonna verify and then I'll get back to you guys in the following lecture. All right. Oh, code? Yeah. Let me put this right here. So yeah. So keep this in mind. I'm gonna try to always do a little bit of math review because the math is always the glue that holds us together, right? And then the rest of it is the MATLAB. So we talk about unit vectors, functions, and for loops. And then here's the code for that. Yeah, so like I said, I'll verify this and then we'll come back to it next week. So hopefully by the end of today, you can solve this by yourself without using this operation. Okay, any questions? All right. So let's get started with the lecture. All right, so today we're covering chapter 4. And so we've already covered a lot. As I mentioned previously, we're doing about a chapter a week. So far, we've been pretty consistent with that. So chapter 4 is learning how to solve systems of linear equations. So raise your hand if you've taken linear algebra. Raise your hand if you have never taken linear algebra. Most of you have taken in this class. That's interesting. So linear algebra is dealing with linear equations. So what is a linear equation? Yeah, mx plus b. So as long as you have like your slope and your intercept, and then you're not doing anything crazy with your trigonometry or anything like that, then that's a linear equation. Okay. Notice how last time we did nonlinear equations, but now we're doing systems. So multiple equations, multiple unknowns, right? And so this is the bread and butter of this class. Like from here on out, you're gonna find that this class is just gonna get faster and faster. So that's why I really want y'all to take the time to just practice MATLAB because it's just going to get faster from here. So that's what this is about. And then, so today we're going to cover Gauss elimination. And then there's also different versions of that. Gauss elimination with pivoting, Gauss-Jordan, LU decomp, inversion, iteration, and then some for loop stuff. So today we're only going to cover Gauss elimination method and then some MATLAB stuff. So if we don't cover it today, does that mean that you're clear? Does that mean that you don't have to study it? No. So if we don't finish it today, you're going to go back and read all these? Yeah? Very good. All right. So the main idea is basically we need a method. We need a way to solve large systems of linear equations. So for example, how many of y'all are chemical engineers again? And then environmental? Yep. So we're chemical and environmental engineers mostly, right? So, sometimes we have some complex reactions, or you might have like your heat transfer, your fluids, and then there might be like electrical engineering systems. They can be very complex, and then also your mechanical systems. So, we can do these by hand. That's what we learn in our classes, doing it by hand. But in the real world, it gets more and more complex very, very quickly, right? So, how would we solve this by hand? We probably just need a computer at that point. So we're going to learn how to solve these using MATLAB. All right. So these are from your book. If you do these problems, I won't give you extra credit, but good for you. All right. So let's start with Gauss elimination. And we're just going to do an example. So let's say we have this system of equations. So go ahead and write that down. And then, keeping matrices in mind, keeping what we learned last quarter in mind, go ahead and get started. You can write it in matrix form. Let's start with that. I want it in that form. That's going to be our first step. Let me know when you finished writing this, because I'm gonna try to, let's see how we can do this today. Let's see that. I'm gonna stop share for a sec. Start video. It's this side. Okay. All right. Okay, that's like directly at me. Yes. So the way we're going to do this, we're going to do some math and then some MATLAB. So if you see I make a typo, just don't be afraid to just, fix that. Okay. So let's start by defining matrix A, 1 by 4. A1, 1, A1, 2. Okay. All right. So let's go over this again. Go back to this. Okay. So we have this template here. We have this formula. So this is straight from your book. And y'all are engineers, so y'all are really good at like taking information and then, this is your tool. This is your tool set. And then I want you to work around these tool sets and then try to manipulate the matrix, get that as your equation, right? So this is your matrix A. We're going to have to write this out manually. And so the goal is to cross out the bottom. We're trying to get these all as zeros, okay? That's going to be an upper triangular matrix. So do you see how this is an upper triangle, right? So we want to get it into that form. So the first step is we have to manipulate the matrix just using algebra. And then we're going to get it in this upper triangular form. So why do we want it in this triangular form? So notice the last row. What's significant about the last row? The units. Go ahead. Yeah. So now you have, this is basically one equation, one unknown. So this is just going to be A44 times X4 equals B4 prime, right? So that's going to be this top equation. So remember, I know it's confusing with the indices, which one's I, which one's J, which one's K, and then N. So this is just the standard that mathematicians like, right? So N, what does N stand for? This number, right? So what is N in this case? Number of what? What do you? So if it's a 4x4 matrix, right? What do you think N is? N is 4, exactly. So here we're solving for X4, and it's B4 divided by A44 right here, okay? And then once we find that, then the rest is just cake, because we can just back solve. This funky looking equation is actually the easy part. So the hard part is figuring out how to convert the matrix, okay? So how do we take that matrix? How do we write that out? How do we get rid of that first zero? So let's do it one at a time, right? So we have this matrix. I'm going to write it like this. Now we're going to plug it in, right? In fact, let's just get started on MATLAB. Okay, so first up, let's just make sure we have the matrix down properly. Here's the matrix. So what should this be? So help me out here. 4, right? 4 minus 2 minus 3, 6, negative 6. Huh?
1, 7.5, 6.25.
Mm-hmm. Perfect. So let's check that, make sure we didn't have any typos. So do we see what I'm doing here? Right? So thank you for just copying this as a matrix, right? So let's make sure this is correct. Raise your hand if you understand what I did there. Yes? So that's that matrix. Second step is let's do our B's. That's just going to be that column on the right, 12, negative 6.5, 16, and 17. All right. And now, so what I want to do, just like last time, I want to augment these, right? A and B. I'm just going to clear the variables because that's my practice. Right? This should be a row vector. Right? So that's what this is going to be. This is going to be that giant matrix right here. So I'll let you see the code. Do y'all mind if I put this up? Can you guys see from here? Yeah? All right, I'm going to put this one up. I need more room. Okay, so I'm just going to manually just do that just to show. Let's see what we have here. Okay, we have A equals that guy. Minus 2, minus 3, 6. This is actually going to be the augmented matrix. Okay, minus 12, minus 6, 7. I think there's a typo here. 5. Right there, negative 6, negative 6.5. 6.5. Right there. Yeah, so that's why it's really important that we have to get all these values correct. Right? 1, 7.5, 7.0, 177, 6.25. Okay. So remember, the thing to keep in mind is that how many rows do we have? We have 4 rows. So each row represents one equation. So when you're looking at this row, I want you to think about each row is a whole equation, right? So this is the entire first row, that's the entire first equation. So how do we call the first equation? Let's say I want MATLAB, I need the first equation. What do you do? Yes. Which would be? We have rows, comma, columns. Is that too far? All right. It's going to be 1, comma, colon. Okay. So that's that first row. 1, comma, colon. So I'll write it for you guys here. So I'm going to say, let equation 1 equal. So in the MATLAB form, it's going to be og 1, comma, colon. So equation 1 represents (4 minus 2 minus 3, 6 equals 12, right? And so what goes right here? 4 x1 minus 2 x2 minus 3 x3. All right, perfect. Let's do one more. Equation 2. So how would I call it with MATLAB? Equation 2. So equation 1 was og 1, comma, colon. Equation 2 is going to be og. Very good. So equation 2 is going to be -6, 7, 6.5 minus 6 equals -6.5. Right here, what goes here? -6 x1 plus 7 perfect. Okay, so we have these two equations. All right, so let's make sure we put this in MATLAB. Let equation 1 equal that, and let equation 2 equal og 2, comma, colon. So if you can't see what I'm typing, I just type this. Okay, so type this into MATLAB, type this one, type that one. All right, and then I'll for sure let you guys see that. So now I'm going to erase this just so we can see the math. Just so we can see the math. Okay, I'll go back to the MATLAB, I promise. Okay, so the goal is goal. What's the goal? The goal is, let's write it right here. The goal. Cancel out the 6, the -6, right there. So we're trying to turn this guy into a 0. So who can tell me what I can do to these equations to get rid of this x1 right here? One more color. Can I add them? Yes. So what do we want to do? Do we want to add E1, E2? Okay. Multiply, say again.
Multiply E2 by 2.
Multiply this by 2.
And E1 by 3.
And then E1 by 3.
And then add E1, E2 plus E1 to replace E2.
So basically, you're saying 2E2 plus 3E1. So we multiply this by 3. 3 times 4, 12. 2 times minus 6 is 12. Add them together. Okay, nice. That could work. That can work. I think what I'm going to do is I'm going to keep E2 constant. So that's going to cancel out. So do you see how that would cancel out? And then you would get your 0 right there. So that is going to work. I'm going to do it a different way. I'm going to keep E2 constant. And so what do I want to do? I'm going to call another variable. So let E2 prime. E2 prime just means new. Okay. So let me know if you guys can't see that. So E2 prime, I'm just going to take my regular E2. So take the entire thing. And then I'm going to subtract. I'm going to subtract E1. E2 minus E1. But I want to multiply by some stuff. So what goes here? Yeah. Yeah. Right? So then for the first term, we would have minus 6 minus 4 times 6 over 4. Right? So then this would cancel out. And then we'd be left with 0 right here. Yeah. Does that kind of make sense? Raise your hand if that kind of makes sense. A little bit. We're a little confused. It's all right. So once you do it by hand once, it's gonna make a lot more sense. Okay. So what that's gonna do. So before we move on, we're gonna do this on MATLAB now. Before we move on, do we have at least an idea of what we're doing? We're manipulating each row one at a time, right? Yeah. Yeah, so that's just keep that in mind. That's all we're gonna do. And if you get confused, I really want you to do it by hand and then translate it to code. So everyone write these down. Now we're gonna do it on MATLAB. Yeah, hopefully y'all can see that. So what I want you to do is, well, let's compute that. So let's change this. Let's change this row. Yeah, let's compute it together. That'll help. So negative 6 minus 4 times 6 over 4. Are the signs correct? Yeah. That's going to be 0, right? So what's going to go for the second row? We need E2, which was 7, minus 6 times 4, 6 over 4. Yeah, the math is going to get ugly, so I don't want to do that math. We do that for each term, right? Following that, for that column, this column. We keep going. And we're changing our matrix. Okay? So is it okay if I put this down again? Back to MATLAB? All right. No. Right. Okay. Full screen this. So this is how I'll wait for that. Yeah. So hope you guys got that one. Okay. So this is how to define the first row. Okay. This is how to define the second row. All right. So now we want to change the second row. Okay. Ooh. There's one more thing. I really wanted to do this. Sorry. One more thing. We have an equation. We just derived an equation. All right. So we have this equation right here, right? This is equation 1, and this is equation 2. So our equation, as we said, all right, the new row E2, this is our new equation. Okay. And then E2, we said, what is that? This is our old equation. This is old of what we want to change. What did I say for the other class? Old minus pivot equation. Okay. Okay. Yeah. So we said this is our old equation. So E1 is like constant, right? So we're just keeping E1 and it's just going to stay there. So this is our pivot equation. Pivot equation. Okay. And then, so we're multiplying by E1. E1 is our pivot equation. Right? So E1, we're just kind of like using it to manipulate E2. And then we're gonna multiply that by, so if this is the pivot equation and we use 4 as the element, this is the pivot element. Pivot element. Right? Hopefully that makes sense. So 6 goes on top. So 6 is just our element that we want to change. Times old element divided by our pivot element. Okay, so this is our equation. This is our equation. Well, yeah, this is our equation. So our goal, we want to convert this to MATLAB. So the new equation is the old equation minus the pivot equation times the old element divided by the pivot element. Okay, hopefully I got that right. Element times the pivot equation. Yeah. All right. Any questions before we go to MATLAB? So now let's go back to MATLAB. Okay. So we want to define our new equation, their old equation, minus the pivot equation times the old element divided by the pivot element, right? So that's our template. Okay. So what's our new equation? Let's just use this as a template, right? So E2 equals, what's our old equation? Still E2. So remember how we can just change the names of the variables in MATLAB? So it's going to replace E2. That's going to be our new equation, where we're using the old equation. So that's new equals old minus the pivot equation, E1, right? Times the old element. So that's going to be looking at E2, right? E2, E21 divided by E11, right? So E2 is our old equation minus E1. That's our pivot equation. E21, we're looking at the matrix. So what I'm doing is I'm trying to visualize the matrix in my head and then trying to translate that into the code. Let's see if that works. Look, it works, right? So we canceled out the 0 thanks to Lexi derived the equation, right? So we figured out how to do it for the entire system. So what I want to do is generalize this a little bit. So I said E2 is this. So I'm just going to replace that. So E2 is og2 comma colon, right? E2 is still og2 comma colon. Look, all I'm doing is I'm just copying, pasting this. I copied it, pasted it right here and right here. Okay. I wish it highlights like it does on the desktop. That's all right. And then E1 is right here. Okay. I'm only doing this so we can kind of like generalize it, right? And then E2. So it goes right here. E2 1. What do I put right here? 2 comma 1, right? And then what goes right here? 1 comma 1. So I didn't do anything different. I'm just translating it. Put it back. Same thing, right? So now we have the whole matrix changing over time. Okay. So that was the second row. Where do we go next? So look, that whole time we only changed one row. So we're not even here yet. We're still on step 1, right? So we cancel out this 1 0. And now we got to get to this 0. We got to go vertically down. Everyone pay attention to this. We're trying to go vertically down. Go like that, right? Put that, zoom in on that. We're going in this order. First, we do that first column, cancel out the zeros, turn them all into zeros. We do the second column, and then that last element. Once we do that, it should look like this. So that's our goal. Okay. I'm going to go quickly now. So this is the nice thing. So I'm just literally copying and pasting. So now we did the second row. Now we're going to do the third row. So this is the new minus the old divided by the pivot equation is constant. The old element is 3. And then the rest is constant. So hopefully that works. Right? So now we have the second element. We do that again. So what goes here now? Og 2, 3, 4 goes right here. 4 goes right here. Constant, constant, constant. 4 goes right there. All right. Okay, so we did the first part. We canceled out that first column. That's pretty good. Making good progress. So now what I'm going to do is I'm going to jump to the for loops. Okay. So how do we do that? So the next step would be to change the third row again. But I want to do some for loops. So now I need to tell MATLAB to shift to the right. Okay. So I'm going to comment all of this out because we're going to do it again. And then do that. The first thing I need to do is define the size of the augmented matrix. So I'm just going to do SA for size. This is lowercase s. Some of y'all are getting a little confused with that. It's lowercase s. That's the size of the matrix. Okay. All right. And so we need for loops. So we kind of briefly discussed for loops previously. Let's just show you how they work real quick. Again, so we have for I to 1 to, let's just say 3. And then I just want to output I. So what should I see here? I run this, what should we see? Yeah. So we just have I is 1, 2, and then it just repeats. Okay. Let me in my code. What if I have a nested for loop? So I have I, and then I have J. So what should I see here? So J is going to iterate first, right? J is going to be 1, 2, 3. I is constant, and then I changes. Okay. So now this is a nested for loop. So how do we use a nested for loop? At this point, I'm just going to just help you all out. And then hopefully you can, I'll give you the template. You can understand what we're doing. And then, you know, use that to for your homework. Okay. So all I want to do is I need to copy this equation. Okay. Are we good on the math, at least for the math? We kind of understand this equation. Raise your hand if you understand the math. Okay, perfect. If we understand the math, we're ready for the MATLAB. So all we have to do is figure out how to adjust the equations. So the first step is we're saying the new, so that's going to be og, and it's going to be j comma colon. Okay. The new is also the old because we're just replacing it. We're just changing the entire row. Okay. The pivot equation is going to be I comma colon. So that's why we need both the I and the J. And then this is going to be, okay, let's finish this, times the old element, which is og j comma I, divided by the new, the pivot elements, og I comma colon. All right. So if this equation looks a little funky, just all I can say is just practice. I don't know how to quite translate. That's just how coding works, right? You just have to learn a language. So MATLAB is a language. Some people would disagree with that statement, but it's a language. And then we should output that. That's og. If that works, then we should be good. Say again. This one, right? Yes, I comma I. Yes. Thank you. Okay, I have a bug somewhere. I need to check that bug. But this is the template. I need to check the matrix. 12 minus 6.5. And then I need to change this. This is the template. Let me get you guys started with your lab, and then I'll check this code and we'll come back to that. All right. So this is going to be size of, and then we're iterating from I plus 1 to size of og 1. Let's see this. Yeah, I gotta check the bug. Sorry about that. I'll check that for you guys. Let's go ahead and show you the lab. So I want you to get started with problem 1. We didn't quite finish. So while you guys get started, translate the matrix. I told you to define this as og, but it seems like some of y'all are having some glitches with that. I'm not sure why. So just go ahead and skip part 1 if it doesn't work for you. But that's just going to be the augmented matrix. And then using what I just showed you, we're going to calculate the x's. Okay. You know what? I think I have the code right here. This should work. There we go. This should work. So this is going to be your upper triangular matrix. So we're almost done. Almost done. All we have to do is solve these. We have to solve this system. So look, we have 4 equations and 4 unknowns, right? So what do we solve for first? X4, good. So now we solve X4. We plug X4 into solve for X3. Now we know X4, X3. We plug it back. We go up, going up the matrix. First you solve X4, you solve X3, you solve X2, you solve X1. That's it. So the hard part is the matrix. And then that's all there is to this. So again, you can skip part A if it doesn't work for you. Let me know if you think there's a glitch, because I think there's a glitch in my MATLAB grader. And then same for number 2, same thing. You have a 3x3 matrix, plug in the algorithm, it should be good for you. Okay. Any questions about that? All right, I'm going to stop recording.